Hello everyone. In this video we're going to use Excel to help us go through a little bit of some basic probability calculations. Now you could use a regular calculator. We really don't need the Jamovi software for this one just because of kind of the nature of this probability question. So let's look at what's being asked. So we have in a large population 52% of the people have been vaccinated. If 5 people are randomly selected, what is the probability that at least one of them has been vaccinated? Okay, so let's kind of break this down a little bit. We have a whole bunch of different little parts, and what we're really going to focus on is trying to get it down into its component parts so that the calculations just kind of fall out. So let's see what is given. So we know that in this population, the probability of randomly selecting one person, so the probability of one person, we'll do one randomly vaccinated, and that would be equal to 0.52. Okay, so that's the probability that a single person has been vaccinated. Now, the probability that we're looking for is this. Okay, so what's the probability that if 5 are randomly selected, at least, let me capitalize that, at least one is vaccinated. Okay, so this is our question. Now, there are some things that we can do, and we can use some of our basic probability multiplication rules, and let's kind of talk a little bit about what would happen if we kind of take it one direction, and we'll see what happens. Okay, so we can easily figure out, let's first we have one randomly selected person is vaccinated. I'm going to shorten that down again to just one vac, and is equal to 0.52. Let's say the complement of that. It might prove to be handy. Probability of not vaccinated, and that's just the complement. So we could do equals 1 minus 0.52, and the probability that a randomly selected person is not vaccinated is 48%. Okay, well, we're trying to do if 5 are randomly selected, at least one is vaccinated. Okay, well, let's do the probability of 5 people being vaccinated. That 5 randomly selected people are vaccinated. 5 random are vaccinated. Okay, and that's just going to be probability of vaccinated times the probability of vaccinated times the probability of vaccinated. You get the idea. We're going to do this 5 times. Okay, 1, 2, 3, 4, 5. Or we could also just say then that's equal to the probability of vaccinated raised to the power of 5. Same thing. And let's see what we get with that. 5. Now let's do probability of vaccinated raised to the power of 5. And that's the probability that we get 5 people and all of them are vaccinated. Okay, that's not quite what we want. Okay, let's hold on to that real quick. Let's try something else. So we can now do the probability of 5 random are not vaccinated. And that's just going to be equal to the probability of not vaccinated raised to the power of 5. And let's do that one. Equals raised to the power of 5. And we get this like 2%. All right, let's look at these and see if these are the questions that we're looking for. So we have 5 random are vaccinated. Randomly selected, all 5 of them are vaccinated. That's like 3%. We have probability of 5 random are not vaccinated, and we've got 2%. But our question is, if 5 randomly selected, what's the probability that at least one of them is vaccinated? Okay, well, so we're not there yet, but we're kind of on the right track. We at least have 5 randomly selected people in them, but we're not there yet. So let's try another step. Let's try to take like the complement of what we worked on. Okay, so let's go down. So let's do the probability of, or let's do the complement of this. So let's do probability of 5 random are vaccinated, and let's do complement of that. So let's put in another parenthesis up C, and let's kind of just theoretically figure out what that would actually mean. Okay, so if we have 5 randomly selected people are vaccinated, that would mean the complement of that would be 1 or more are not vaccinated out of 5. Okay, that's not quite what I'm looking for. Let's do... Okay, so that wasn't quite right. So let's try to take the complement of this other one. So the probability of 5 random, sorry, okay, so let's look at this one. So if we do 5 random are not vaccinated, complement. Well, if we do that, that's actually the probability. So if all 5 are not vaccinated, the complement of that would be any other combination of those 5 where at least 1 is vaccinated. 1 or more are vaccinated out of 5. And hello, I think that we finally got there. So we are looking for the probability of 1 randomly selected, if 5 are randomly selected, at least 1 is vaccinated. And we got down here finally with taking the complement of this one right here, where probability of 1 or more vaccinated out of the 5, which is what we were looking for. So in order to do that, we would do 1 minus this probability that we calculated. And we have there's a 97% chance, so 0.9745, that at least 1 had been vaccinated. Okay, so we kind of went down one rabbit hole, and I took you down it on purpose just to show you what this does, so that you could see it's like, okay, if you just take this probability of vaccinated, raise it to the power 5, and then do 1 minus, that's 1 or more are not vaccinated, and this one is 1 or more that they are vaccinated. Anyhow, so that's kind of how you get through these. So these at least questions are kind of famous, and anyway, so there's a handy way to get through them. Now, one thing that we have to realize is that we must make the assumption to use this equation that all of the events are independent from one another. That just selecting one doesn't change the probability of somebody being vaccinated or not. If they are dependent, there's another equation that we use, and we can look at that in at a different time. But this is how we deal with it if they are independent, how to do an at least question. Best of luck on your own calculations.